Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed mole concept and equivalent weight. Now I will continue. Gram equivalent weight. What is the gram equivalent weight? The equivalent weight of a substance expressed in grams is called gram equivalent weight or 1 gram equivalent. Again you listen. The equivalent weight of a substance expressed in grams is called gram equivalent weight or 1 gram equivalent. Now relationship between equivalent weight, atomic weight and valency of an element. Actually this relation is very important. Relation between equivalent weight, atomic weight and valency of an element. Very important relation. Then you remember this relation. Equivalent weight is equal to atomic weight divided by valency. Equivalent weight is equal to atomic weight divided by valency. This is a very important relation. If you are knowing any two, third you can know. Now next I am going to tell Dulong and Petit's rule. Dulong and Petit's rule. D-U-L-O-N-G. Dulong and Petit's. P-E-T-I-T-S. Dulong and Petit's rule. This is also very important relationship. For any element, atomic weight into a specific heat is equal to 6.4 approximately. Approx. Again you listen. Atomic weight into a specific heat is equal to 6.4. This is approximate. Hence, if you are knowing either atomic weight or a specific weight, then other you can calculate. But you will get approximate only. Whatever value you will get, approximate. Then atomic weight into a specific heat is equal to 6.4. Hence, approx atomic weight is equal to 6.4 divided by a specific heat. Now, empirical formula. Empirical formula. What is empirical formula? It is the simplest formula of a compound which gives the simplest whole number ratio of the atoms of the various elements present in one molecule of the compound. Example, empirical formula of glucose. Glucose formula is C6H12O6. This is the glucose molecular formula. Then what is its empirical formula? Then I told you it is the simplest formula of a compound which gives the simplest whole number ratio of the atoms of the various elements present in one molecule of the compound. Then here one molecule of the compound, that is a glucose, C6H12O6. Then its empirical formula is simplest ratio CH2O. CH2O. C6H12O6. Correct? Then take simple ratio, simplest. Then C6H12O6. then C is 6, H is 6, and H is 12. Hence you can write CH2O. CH2O. Then this CH2O is called empirical formula. Okay. If you multiply it with if you multiply it with 6, then you will get that molecular formula you will get. Correct? Then this is a simple ratio, is the simplest formula is CH2O. CH2O. What is a molecular formula? Just now I told you molecular formula. It is the actual formula of a compound which gives the actual number of atoms of various elements present in one molecule of the compound. That is the molecular formula of glucose is C6H12O6. This is the molecular formula, C6H12O6. Then this is the actual formula of a compound which gives the actual number of atoms of various elements present in one molecule of the compound. Okay. Example, molecular formula of glucose is C6H12O6 and its empirical formula is CH2O. Now next I am telling you relationship between empirical formula and molecular formula, how both are related. This is also very, very important while solving the numericals. In organic chemistry also numericals is asked, and numericals will be based on this empirical formula. Generally that numericals is asked from this chapter. Okay, that sometimes they will give some ratio of compound, means elements of the compound, and you have to calculate, you have to tell empirical formula. From the data you have to tell empirical formula of the compound. Okay, then that time you will require this relation, molecular formula, empirical formula, and now I am telling you relationship between empirical formula and molecular formula. Okay, then what is that formula? Molecular formula is equal to N into empirical formula. Molecular formula is equal to N into empirical formula, where N is any integer such as 1, 2, 3, etc. Then now from this formula you can know the value of N. N is equal to molecular mass divided by empirical formula mass. Small n is equal to molecular mass divided by empirical formula mass. Correct? Remember this relation, molecular formula is equal to N into empirical formula. Then N is equal to molecular formula mass divided by empirical formula mass. Okay, molecular mass divided by empirical formula mass. Okay. Now next I am telling you calculation of empirical formula mass. How will calculate calculation of empirical formula mass? It is obtained by adding the atomic masses of the various atoms present in the empirical formula. Just like molecular formula, you are adding the atomic mass to all atoms. Correct? You are adding the mass of all atoms. That is called molecular formula. Like that way, empirical formula, In empirical formula weight, empirical formula mass, how will you calculate? Then empirical formula you are knowing. Then add the atomic mass of empirical formula. Just like CH2O. Then just write the C is equal to 12, 2H is there, the H into 2 into 1 plus O is then 8. You add all. Means 12 plus 2 plus 8. That is the empirical formula mass. CH2O. 12 plus 2 plus 8. How much it will come? Then 12 plus 2, 14. And 14 plus oxygen. That is a 16. Correct? Then total you can write. That is a 20 plus 16. 20 plus 16, 36. Okay. 8 is the atomic number. You remember, 8 is the atomic number of oxygen and 16 is the atomic mass. Now, next I am telling you calculation of molecular mass. Then molecular mass you can calculate easily by adding the atomic mass, various atomic mass of the molecules. But here I am telling you different relation. That is the molecular mass is equal to 2 into vapor density. Molecular mass is equal to 2 into vapor density. In shortcut, it is called VD, means vapor density. Then what is the vapor density? Then vapor density is equal to weight of certain volume of gas divided by gas or vapors, anything. Weight of a certain volume of a gas or vapors divided by weight of same volume of H2, means hydrogen gas, under same condition of temperature and pressure. Means here just weight of certain volume of gas or vapors. If you are knowing, then you compare with weight of same volume of hydrogen gas. Correct? Any other gas divided by same volume of hydrogen gas. Means in comparison to hydrogen gas, how much that gas is more or less in comparison to hydrogen gas. Hence vapor density is equal to weight of certain formula of a gas or vapor divided by weight of same volume of H2. Both are weight, and these hydrogen gas weight of the same volume of hydrogen gas and weight of the given gas. Both weight is required. Weight of certain volume of a gas divided by weight of same volume of H2 under same conditions of temperature and pressure. This is the first relation. Molecular mass is equal to 2 into vapor density, and vapor density I told you weight of certain volume of gas or vapors divided by weight of the same volume of H2 under same condition of temperature and pressure. Other relation is molecular mass is equal to mass of 22.4 liter of gas at STP, standard temperature and pressure. Molecular mass is equal to mass of 22.4 liter of gas at STP. Now next things I am going to tell you calculation of empirical formula. Calculation of empirical formula. Here you can see data. If data is given, then how will you calculate? That method I am briefing you. While solving the numericals, this process will be useful. Okay. Then how will you calculate? Then first calculate percentage of oxygen. Actually, different atoms percentage will be given, like hydrogen. Suppose glucose is there. For glucose or any other unknown, carbon percentage is given, oxygen is given, hydrogen is given, nitrogen is given. Correct? Suppose it is there. Four elements are there. Then there, suppose percentage is given. Oxygen percentage is not given. Oxygen percentage is not given out of 4. 3 are there: carbon, hydrogen, oxygen. Carbon, hydrogen, nitrogen is there. Oxygen is not there. Suppose this type of compound is there. Then how will you calculate empirical formula? If suppose in molecule 4 different atoms are there: carbon, oxygen, hydrogen, nitrogen. Then oxygen is not given, other percentage is given. Then you have to find out empirical formula. Then how will you calculate? Then that I am telling you now process. Okay. And when I will discuss numericals, that time only that you remember this process, okay, or methods. Then first what you have to do, you calculate the percentage of oxygen, because out of 4 or 5 any one will be not there. Oxygen generally it will be not given. Then other will be given percentage. Or you will calculate also. If not given, then they will give the mass. They will give the mass of carbon, hydrogen, nitrogen. Then percentage you can calculate. Correct? Then first of all, you calculate the percentage of oxygen. Then how will you calculate? Then percentage means 100 out of 100. Then from the 100 you add can say sum of percentage of all other elements like carbon, hydrogen, nitrogen. You add all percentage and deduct it from the 100. Then that will be oxygen percentage. Then now all percentage you are knowing. All 4 was there, 4 you are knowing. Then actually in this numerical, to solve this numericals, you have to make one table. You have to make one table. In that table, you have to make various column. Column you can tell, column only you can tell. That table you have to make. Then just in that table, first column you write element, and in second you write percentage of elements, second column. Third, atomic mass of that elements, and fourth column will be of or group, whatever you want you can tell. Okay. In periodic table, no, horizontally it is known as column and vertically it is group. In that way, then first group you can tell, you will remember quickly, then element. Second will be of percentage of that element, and third will be of atomic mass. Fourth will be relative number of atoms. Relative number of atoms. This you have to calculate. Then how will you calculate? Then very easy method to calculate relative number of atoms. That is the percentage divided by atomic mass. Percentage divided by atomic mass. This is actually main things. After that, all things are easy. Okay. Then here, relative number means relative means always you have to compare. Okay. Then relative number of atoms you will calculate percentage divided by atomic mass. This formula you remember. This is the main important. After that, if you will calculate the relative number of atoms, suppose as for example, hydrogen is suppose 20%, then 20 divided by 1.008. Hydrogen atomic mass is 1.008. Roughly 1 you can write. Then 10% means 10 divided by 1, 10. Like that way, if suppose carbon is 60%, suppose, then 60 divided by 12, then you will get 5. That time you got 10 divided by 1. In case of hydrogen, 10 divided by 1 means 10. 10 number of hydrogen. And here 60 divided by 12 means 5 number of carbon. Nitrogen, suppose it is 14. Suppose, then 14 divided by 14. 14 divided by 14. 14 is the atomic mass of nitrogen. Then 14 divided by 14. That is the one. Number of nitrogen is number of nitrogen atom is n. And number of nitrogen atom is 14 by 14, that is the 1. Suppose it was 28, then 28 divided by 14, then 2. Like that way you will calculate the this relative number of atoms. After that, all things are easy. Next column means the next group we can write simplest atomic ratio, because now atom suppose it is there 5, 10 was hydrogen, 5 was carbon, nitrogen was suppose 1. Then what is the ratio can calculate? Okay, ratio, simple ratio you have to write. Correct? For your easy understanding, I am telling you that suppose hydrogen was 5, hydrogen was 10, carbon was 5. Correct? And nitrogen, you can tell any other value, or what you consider, like this we consider 363, or not this, it will not fit. You can consider as hydrogen as 4. Hydrogen you consider as 4, and this you consider as carbon consider as 2. Then 2 is, this will become 2 is to 2. 4, 2, 2, like that you consider 4, 4, 8, 4, like that, 4, 8, 2. Then minimum if you take the ratio, then 2 is to 4 is to 1. Correct? Like that way, next column you have to write simplest atomic ratio. And sometimes this value will be not exact, it will come in fraction, like 1.28, like that way it will come. Sometimes it will come 1.98, then 1.98 is close to 2, then you can write 2, roughly 2 you can write in whole number. Finally you have to convert whole number. Then if it is 1.8, 1.9 like that, then you can write 2. Okay, you can write 2. If it is less than 0.5, 1.5, less than 1.5, like 1.4, 1.3, then you write that 1 only 1. Okay. if more than point, like 0.6, 0.7, 0.8, then you can make it as a 2, particularly 0.7, 0.8, 0.9, like that. Okay, and less than 0.5, then don't count that 0.5, don't count. Then that is called simplest whole number ratio. Then now, if you are knowing the simplest whole number, suppose carbon was suppose 2, hydrogen value came 4, nitrogen value came n. Then what is the empirical formula? Easily you can write. See, they can write according to that carbon, hydrogen, nitrogen, what is their number, you write, that's enough. Now, in examination, you have to solve many numericals. Then what are the steps involved in solving problems based on chemical equations? How will you solve? Okay, based on chemical equation. Then I am telling you steps. That is, I am telling you numericals based on chemical equations. Then first step is write balanced equation for the reactions involved. Balanced equation first to write. Balanced equations for the reaction involved. Reaction must be balanced. Correct? Second step, write the relative number of moles or relative masses of the reactants or products involved in the problem. Below their formula you write. Either you write number of moles, you are writing a balanced equation 3H, you can write 3 calcium carbonate plus 2 H2O, like that way you are writing. Then 3 means 3 moles, 2 H2O means 2 mole. Product, suppose it is forming 4 H2O, suppose 4 CO2, then product is 4 CO2 and other, suppose HCl is there, 3 mole. Then that is also telling mole. What is the coefficient? That is the telling number of mole. Okay, then below the formula you write the number of moles or relative masses you have to write. Okay, write the relative number of moles or relative masses of the reactants and products both involved in the problem below their formula. Third step, in case of gaseous substances, write down the 22.4 liter at STP. You must write. Actually, that also vapor density, what I told you, that is applied. That is applied for gas only. Molecular mass is equal to 2 into vapor density, Vd. Then that you will apply only for gaseous reaction. Here also I am telling you same way. In case of gaseous substances, write down 22.4 liter at STP below the formula in place of 1 mole. You know that 1 mole is equal to 22.4 liter. Easily you can know the volume. 1 mole is equal to 3 relations are there. 1 mole is equal to 22.4 liter at STP or 22,400 ml at STP. This is first relation. Second relation, mole is equal to atomic weight also or atomic mass. Third mole is equal to molecular mass. And fourth relation, mole is equal to Avogadro number. Hence, if you are knowing the mole, then all three you can know. Means atomic mass or molecular mass you can know, and number you can know. Number of atoms or molecules, anything you can know. and volume also you can know. Then this third step I told you, write the relative number of moles or relative masses of reactants and products involved in the problem. Below their formula you should write. Now this also I told you to write. Third step. First step I told you to write the balanced equation. Second step, relative number of moles or relative number of relative masses of reactants or products involved in the problems. Below their formula. Third step, that in case of gaseous substance, write down 22.4 liter at STP below the formula in place of 1 mole. If volume is involved, then 1 mole is equal to 22.4 liter you must write, okay, below the formula. And last means fourth step, apply unitary method to make the required calculation. Okay, last step, apply unitary method to make the required calculation. Correct? Now last point, today's class last point, I am discussing limiting reactant. Limiting reactant, this is very very important. The reactant which is present in a smaller amount and reacts completely and hence decides the amount of the products formed is called the limiting reactant. Again you remember, the reactant which is present in a smaller amount in a smaller amount and reacts completely and hence decides the amount of the products formed is called the limiting reactant. In reaction you might have seen that sometimes one reactant may be of more quantity, other may be little less, and one third one may be very less. Very less means the smallest. Then obviously that will react completely and it will give the full product. That will react completely. After the reaction, nothing will that reactant will not remain. Correct? For the reaction all are required, all three are required. Then maybe first two maybe little less, but that is sufficient for the list. For the list reactant that maybe both sufficient. Correct? Then list which list quantity, reactant which has list quantity, that actually decides the products, amount of the products. Okay, and that is called the limiting reactant. Means quickly you can understand by writing all the things mole wise also, which is in less mole. Suppose reactant wise one was 3 mole, other was 4 mole, and one was only 1 mole. Then 1 mole will be the limiting reactant. Okay. Then today I am stopping only here, and next class I will discuss additional advanced information. Okay. Slowly and slowly now I think by next class, that will 1-2 class maximum, this will finish. Then I will come to the numerical problems. Okay. Thank you.